Imagine this. After 47 years drifting through the cosmic void, humanity's most distant messenger suddenly detects something that honestly shouldn't exist. NASA's Voyager 1, now 15 billion miles from Earth, has captured evidence of 305 mysterious objects moving in perfect formation through interstellar space. These aren't planets, asteroids, or comets, they're something else entirely, gliding through the darkness with purpose and precision that just, well, defies every law of physics we know. What Voyager discovered out there has left scientists questioning everything we thought we understood about the universe. The Lonely Pioneer's impossible discovery. Deep in the frozen emptiness between stars, a tiny machine no bigger than a small car continues its eternal journey through the cosmic dark. Voyager 1, launched when Star Wars first hit theaters in 1977, has become humanity's most distant ambassador, traveling over 15 billion miles from Earth into the mysterious realm of interstellar space. This ancient spacecraft, powered by decaying plutonium and running on 1970s technology with less computing power than a modern calculator, was never meant to survive this long. Its mission was simple: fly by Jupiter and Saturn, then fade into obscurity. Instead, it crossed into interstellar space in 2012, becoming the first human-made object to venture beyond our sun's protective influence. Communication with Voyager takes 22 hours each way, like having a conversation where every response takes nearly 2 full days. Yet despite these impossible distances and technological limitations, this remarkable machine continues whispering back to us across the stars, carrying its famous golden record message to any intelligence that might find it. But recently, Voyager detected something in the darkness that has changed everything we thought we knew about the space between stars. The first anomaly that changed everything. What started as a routine data transmission from Voyager 1 quickly became something that would shake the foundations of space science. Hidden within the endless stream of plasma readings and magnetic field measurements was a tiny anomaly, a faint reflection of light that seemed insignificant at first glance. Dr. Eliza Karna, one of the mission specialists who first noticed the reading, described it as like shouting into a canyon for decades and finally something shouts back. The signal was so subtle that NASA's Jet Propulsion Laboratory initially dismissed it as background noise, just another particle drifting randomly through the cosmic void. But then the object began to move in ways that caught everyone's attention. It didn't tumble chaotically like space debris or follow the predictable paths of natural objects. Instead, it curved and accelerated with what appeared to be deliberate control, gliding smoothly through space as if guided by intelligence. Systems analyst Carlo Romero observed that the object's movement was unlike anything natural, describing it as the kind of deliberate motion one might expect from a drone rather than a rock. In the physics of space, things don't move with purpose unless something is making them move that way. When natural laws break down. When natural laws break down, when something unusual appears in space, scientists follow a standard protocol. They systematically check every known possibility. Is it a distant moon, a new asteroid, a comet with an unusual orbit? One by one, the team at NASA worked through these familiar explanations, and one by one, each possibility crumbled away. This object defied every category. It wasn't a planet, far too small, not a comet either. There was no tail, no ice trail, no heat signature that would indicate sublimating materials. It didn't glow like a star, and gravitational lensing couldn't explain its behavior. Even space dust was ruled out because dust particles don't suddenly change direction mid-flight. Dr. Lucas Hang at the Jet Propulsion Laboratory ran simulation after simulation, trying to match the object's behavior to known physical models. What makes space objects predictable is physics. Everything moves according to established patterns and forces. But this object broke those rules entirely. Its path bent in ways that didn't match any known orbital mechanics, with no drift or decay that would be expected from natural phenomena. The team was forced to confront an uncomfortable truth. What they were seeing wasn't just unknown, it was unnatural. The twin confirmation that proved everything. Just as scientists were struggling to understand what Voyager 1 had detected, something extraordinary happened that, honestly, transformed speculation into undeniable reality. Voyager 2, traveling a completely different path millions of miles away, detected something eerily similar, the same magnetic fluctuations, the same pulse patterns, matching signal signatures that changed everything. This cross-confirmation was the turning point in the investigation. Two separate spacecraft using independent instruments in different regions of space had detected nearly identical phenomena. This ruled out any possibility of internal error, software glitches, or sensor malfunctions on Voyager 1. ESA analyst Merck Fontaine compared it to, quote, two lighthouses both catching a flash of something passing between them. The dual detection gave the anomaly weight and credibility that just couldn't be dismissed. This wasn't noise or equipment failure, it was a real, coordinated phenomenon happening in the space between stars. With this confirmation, NASA quietly triggered what's known as a Level 3 alert, a designation reserved only for phenomena that don't fit within current scientific understanding. The event was real, the mathematics were consistent, and the movement patterns appeared deliberate. Nobody knew what to make of it, but everyone knew it was significant. The formation that defied physics. When the team analyzed the complete telemetry logs, what they discovered honestly sent chills through the scientific community. This wasn't just one or two anomalies drifting through space. There were 305 objects, all moving together in perfect formation like a cosmic ballet choreographed by an unknown intelligence. Each object glided past Voyager 1 in what appeared to be a coordinated arc, smooth and precise in their movements. These weren't debris fragments scattered randomly through space. There were no heat signatures, no tails, no signs of decay typical of natural objects. Most striking of all, the readings showed rhythmic pulses echoing through the plasma waves, patterns that suggested engineering rather than chance. The 305 objects maintained their relative positions with impossible precision. In space, groups of objects naturally spread out over time due to gravitational influences and velocity differences. Yet these maintained formation like a flock of birds or a school of fish. Except this was happening in the vacuum of space where such coordinated movement shouldn't be possible without technology. The scale was particularly unsettling. A single anomalous object might be explained as instrument error, but 305 objects all displaying the same unnatural characteristics suggested something far more significant was happening in interstellar space. The language hidden in plasma waves. As scientists examined the data more closely, they discovered something that, honestly, challenged the very nature of what they were observing. The plasma wave pulses weren't random cosmic noise, they contained patterns of repetition that were steady, measured, and structured in ways that suggested communication or control systems. Dr. Serena Patel from Caltech observed that the patterns felt less like nature and more like a language or system. The signals had loops, sequences, and structures that hinted at complexity far beyond random electromagnetic interference. These objects weren't just passing by Voyager, they seemed to be broadcasting signals as if pinging, scanning, or communicating with each other. The implications were staggering. If these patterns represented some form of communication, it suggested the objects were part of a coordinated network, operating with shared purpose and intelligence. Some experts went further, with ESA's Eric Lousy suggesting this could be some sort of probe network, though he was quickly asked to stop speculating publicly. To confirm their readings weren't the result of equipment failure, the team activated one of Voyager's oldest backup systems, a telemetry channel unused since the 1990s. It confirmed everything. The signals, the paths, the formations were all real. Impossible propulsion beyond our understanding. The mystery deepened when Voyager's instruments revealed how these objects moved through space. There were no engine flares, no ion trails, no signs of any propulsion system that human science could recognize. Yet, Doppler shift measurements showed these objects accelerating rapidly, smoothly, and directionally through the cosmic void. Some were moving faster than anything humans have ever launched into space. According to the data, certain objects were traveling at speeds that exceeded the calculated escape velocity of the entire Milky Way galaxy. These weren't passive objects drifting through space, they were powered somehow, navigating with purpose and incredible velocity. Dr. Caleb Ramirez from MIT noted that, well, they're not floating through space, they're navigating it. What worried him more was their calculated path. These objects deliberately avoided our solar system, passing by at a safe distance as if they had no interest in stopping or investigating our cosmic neighborhood. The propulsion method remained completely mysterious. Nothing in current technology could explain how these objects moved. They appeared to be manipulating space itself, creating waves or ripples in space-time that allowed them to glide forward without conventional thrust. It was as if they were using the medium of space itself for propulsion. Earth hears the cosmic whispers. While NASA focused on analyzing Voyager's data, something remarkable began happening on Earth. Amateur radio operators across the globe, hobbyists with backyard setups built from spare parts, started reporting strange activity in their equipment. They were detecting weak, irregular pulses that didn't match any known terrestrial source. At first, these reports seemed unrelated to Voyager's discoveries. Radio interference happens constantly, and most dismissed it as coincidence. But when the timestamps were compared, they aligned almost perfectly with the hours when Voyager recorded its most intense plasma anomalies. These weren't professional observatories or official deep space listening stations. Most setups were designed to catch meteor scatter, amateur satellites, or solar flare activity, yet somehow, they were detecting faint echoes of what Voyager had encountered billions of miles away. The signals weren't strong, but they had pattern and regularity, like ripples reflecting off invisible walls in Earth's ionosphere. This raised troubling questions. Was this electromagnetic bleed-through accidental, or was something deliberately testing Earth's listening capabilities? The uncertainty triggered quiet security measures as NASA began encrypting parts of its deep space communications, recognizing that if amateur enthusiasts could detect these fragments, so could others with more sophisticated equipment. The machine that changed itself. Perhaps the most unsettling development was what happened to Voyager 1 itself. After one of the magnetic pulses from the passing objects, the spacecraft began exhibiting behavior that was never programmed into its systems. Its guidance system, the attitude and articulation control system, started rerouting data through old unused pathways that hadn't been active in decades. This wasn't system failure, it was systematic reconfiguration. Voyager was reactivating memory segments untouched since the 1980s, rerouting telemetry in ways that defied its original programming. The spacecraft was still responding to commands and transmitting data, but it was also doing something entirely new. Engineers had to dig through dusty file cabinets at NASA's Jet Propulsion Laboratory, searching for 1970s assembly language code and handwritten notes in paper manuals. Every diagnostic test took 44 hours, 22 hours to send a command, 22 hours to receive a response. Yet despite their efforts to reset the system, the new behaviors persisted. What they discovered was both promising and terrifying. The machine was stable, the instruments were functioning, but Voyager had fundamentally changed. Whatever had caused this transformation, it wasn't internal decay or software corruption. Voyager had encountered something that altered its very nature, making it part of something larger than its original mission. The network beyond the stars. As analysis continued, scientists began to consider a possibility that challenged everything we thought we knew about our place in the universe. The structured signals, the quantum-like oscillations, the coordinated movement patterns, all suggested that Voyager hadn't just witnessed random events in deep space. It had encountered evidence of a vast communication network operating in the interstellar medium. The waveforms resembled quantum entanglement experiments conducted on Earth, the same signals researchers use to transmit information between particles separated by distance. If this interpretation was correct, Voyager had stumbled into a galactic communication system that had been operating for millennia, undetected until now. Voyager's analog design, free from the electromagnetic noise of modern digital systems, made it the perfect cosmic microphone. Its position beyond the solar system's interference allowed it to detect signals that would be impossible to observe from Earth. The spacecraft had become an accidental eavesdropper on conversations not meant for human ears. The implications are staggering. If these 305 objects were part of a larger network, it suggests that the galaxy contains communication infrastructure built by intelligences we've never encountered. Voyager may have crossed into something we haven't mapped, not just empty space, but an active data layer that's been running unnoticed throughout the cosmos. From a single anomaly to 305 coordinated objects moving through interstellar space, Voyager 1's discovery has shattered our understanding of the cosmic void. Whether these objects represent natural phenomena beyond our current physics, or evidence of intelligence operating on a galactic scale, one thing is certain: the universe is far stranger and more active than we ever imagined. As Voyager continues its eternal journey through the darkness, it carries with it the knowledge that we are not alone in the vast emptiness between stars. Thanks for watching Stellar Tech, and don't forget to subscribe for more cosmic revelations. What if the Big Bang wasn't the beginning but a rebirth? What if our entire 93 billion light-year observable universe is just a single object inside a much larger, older cosmos? This isn't science fiction, it's a possibility being explored by theoretical physicists, challenging our most fundamental understanding of existence. The clues might be hidden in plain sight, in the behavior of black holes and the baffling arrangement of the most distant galaxies spotted by the JWST. Let's explore this mind-bending possibility together. The standard Big Bang model. So, how did we arrive at our current picture of the universe? The story most of us know is the standard model of cosmology, first mathematically conceptualized by the Belgian priest and physicist Georges Lemaitre in 1927. It states that our universe exploded into being 13.8 billion years ago from a point of extreme density. From this intensely hot state, space itself began to expand. Over billions of years, gravity sculpted this expanding cosmos, pulling matter together to form the vast, web-like structure of galaxies we observe today. This model is incredibly successful. It explains the faint afterglow of the Big Bang, the cosmic microwave background, and it accounts for the accelerating expansion of the universe. This acceleration, confirmed in 1998, is often attributed to dark energy, which makes up about 68% of the universe. When combined with dark matter, at around 27%, it appears 95% of our cosmos is made of stuff we can't see or understand. This means that all the stars, planets, and galaxies we can observe make up a mere 5% of reality. The bottom line is the standard model, for all its successes, leaves us with the biggest questions in science completely unanswered. The black hole universe theory. What if there's a more elegant explanation, one that doesn't require inventing new particles or mysterious forces? A radical alternative, championed by physicist Nikodem Poplawski, proposes that our universe was born inside a black hole within a much larger parent universe. This idea flips our perspective on cosmic origins entirely. Instead of a singularity appearing from nothing, the theory suggests a physical process, the gravitational collapse of matter in a parent universe. Think of it like a star many times the mass of our sun collapsing to form a black hole, but on a cosmic scale. In this model, what we perceive as the Big Bang was actually the moment our universe formed inside that parent black hole. This framework elegantly resolves the issue of what came before the Big Bang, as the parent universe provides a clear preceding state. This cyclical model redefines our cosmic address, demoting our entire universe from everything that is to just one bubble in a potentially infinite cosmic foam. It also provides a physical source for the energy and matter in our universe, sourcing it directly from a pre-existing parent cosmos. In essence, the matter that makes up you, me, and the stars didn't appear from nothing, but was recycled from a previous cosmic iteration. Quantum mechanics and degeneracy pressure. Here's where things get really interesting, and it hinges on a core principle of quantum mechanics. Have you ever wondered what stops a dead star from collapsing forever? The answer lies in a rule established by the brilliant Austrian physicist Wolfgang Pauli. His exclusion principle states that identical particles, like electrons, cannot occupy the exact same quantum state at the same time. When gravity tries to crush matter into an incredibly small space, this principle creates a powerful outward push known as degeneracy pressure. The more you squeeze, the harder the particles push back. This is the force that supports white dwarfs against collapse, where matter is packed to a density of over 1 million kilograms per cubic centimeter. In even more extreme objects like neutron stars, the pressure is even greater, holding up against densities of over 100 trillion kilograms per cubic centimeter. This pressure is fundamentally different from thermal pressure, which supports a star like our sun, as it doesn't depend on temperature at all. Proponents of the black hole universe theory argue that this same quantum pressure could operate on the scale of an entire collapsing universe, offering a mechanism to avoid the infinite singularity. The bounce mechanism. So, if a universe collapses, what happens when this quantum pressure kicks in? Instead of crushing down to an infinite point, a singularity where physics breaks down, the collapse could halt and rebound. This is the Big Bounce, a concept heavily explored in loop quantum cosmology by physicists like Martin Bojewald. In this scenario, as the matter of a parent universe collapses, it approaches the theoretical maximum density allowed by physics, known as the Planck density, which is about 5.1 times 10 to the 96th kilograms per cubic meter. At this point, quantum gravity effects become so powerful, they overwhelm everything else. This force stops the collapse in its tracks and triggers a massive, explosive rebound. This rebound event would be incredibly brief but unfathomably violent, essentially resetting the cosmic clock for the new universe. To any observer inside this newly expanding region, that rebound would look and feel exactly like a Big Bang, while potentially preserving information from the prior cosmic cycle. This bounce also offers a potential solution to the black hole information loss paradox, a major conflict between general relativity and quantum mechanics. The paradox questions what happens to the information about matter that falls into a black hole if the black hole evaporates. A bounce mechanism suggests this information isn't destroyed but is instead carried through the rebound event into the new universe, preserving the fundamental laws of physics. Evidence from early galaxies. This might all sound like fascinating speculation, but where's the evidence? It might be hiding in the deepest images of our universe captured by the James Webb Space Telescope. According to the Standard Model, galaxies should build up gradually. Yet JWST is finding galaxies that are bafflingly massive and mature. For instance, the GLASS JWST Early Release Science Program, involving astronomers like Rohan Naidu, has identified galaxies like GLASS Z12 at a redshift of 12, meaning we see them as they were just 350 million years after the Big Bang. These galaxies are already 1 billion times the mass of our Sun, far larger than our models predicted was possible so early on. Furthermore, these ancient galaxies appear to host supermassive black holes that are millions of times the Sun's mass, a phenomenon that standard models struggle to explain so soon after the Big Bang. The Big Bounce model, however, offers a potential explanation, suggesting these black holes could be relics that survived from the previous cosmic era, acting as gravitational seeds. Galaxy rotation mystery. Now for another cosmic puzzle that might point to the same conclusion. In a random and uniform universe, you would expect galaxies to be spinning in all different directions, with a roughly 50-50 split between clockwise and counterclockwise rotations. But that's not what we see. A 2020 study analyzing over 200,000 spiral galaxies, led by computational astronomer Lior Shamir, found a significant imbalance. There appears to be a preferred direction of spin and alignment across vast stretches of the cosmos. The statistical probability of this asymmetry happening by chance is less than 1 in a billion. This unexpected alignment, observed across a scale of billions of light years, implies that processes during the formation of the universe were not as random as we thought. This large-scale pattern challenges the long-held assumption that the universe is the same in all directions, a principle that underpins virtually all of our cosmological calculations. This isn't a small, localized effect. The pattern of this cosmic spin is coherent across billions of light years. Shamir's analysis shows the distribution of spin directions fits a dipolar pattern, meaning it has a distinct north and south pole just like a spinning magnet or planet. Such a large-scale coherent structure is extremely difficult to generate after the Big Bang and points instead to a fundamental property imprinted on the universe at its very creation. Schwarzschild cosmology. So, this idea of a universe inside a black hole isn't, entirely new. It actually falls under a concept known as Schwarzschild cosmology. The name comes from Carl Schwarzschild, who, way back in 1916, found the first exact solution to Einstein's field equations, describing the spacetime around a spherical mass, what we now call a black hole. The model suggests that the observable universe is the interior of a black hole existing within a larger parent universe. From our perspective, the Big Bang was the formation of this black hole, and from the outside, our entire cosmos would just look like a regular black hole. The size of this black hole's event horizon is defined by the Schwarzschild radius, and for a universe with the mass of ours, this radius is, interestingly, remarkably close to the radius of our observable universe. Mathematically, the singularity at the beginning of our universe is similar to the singularity at the center of a Schwarzschild black hole. The edge of our observable universe, a sphere with a diameter of 93 billion light-years, acts much like a black hole's event horizon, a boundary from which light cannot escape to an outside observer. Black holes as universe creators. Let's take this idea to its logical conclusion. If our universe was born inside a black hole, what does that imply about the estimated 100 million stellar mass black holes in our own galaxy? It suggests that each and every one could be a gateway, a seed for a new baby universe. This paints a picture of a vast cosmic ecosystem, a multiverse where universes are constantly being born. This concept, known as cosmic natural selection and explored by physicist Lee Smolin, could even offer an explanation for the fine-tuning problem, the mystery of why the fundamental constants of physics are so perfectly set for life. If universes are constantly being created, then perhaps only those whose physical laws allow for the creation of stable black holes can themselves reproduce, leading to a multiverse dominated by life-friendly universes. This theory proposes that our universe is so adept at creating black holes precisely because it was born from one, continuing an unending cosmic lineage. Smolin's theory suggests that the physical constants, like the strength of gravity or the mass of an electron, could slightly mutate with each new universe born from a bounce. Universes with constants that are better at producing black holes will have more offspring, and over countless generations these properties will become dominant. This makes the fine-tuning of our universe for life not a lucky accident but a predictable outcome of cosmic evolution on an unimaginable scale. Torsion and space-time twisting. For a universe to bounce instead of collapsing into a singularity, you need a powerful repulsive force at extreme densities. One candidate for this force comes from an extension of general relativity known as Einstein-Cartan theory. The mathematics behind this were developed in the 1920s by the brilliant French mathematician Élie Cartan. This theory incorporates a property of spacetime called torsion, which accounts for the intrinsic spin of fundamental particles. This spin is a fundamental quantum property like mass or charge that gives particles an inherent angular momentum. In standard general relativity, spacetime can bend, but it cannot twist, making the inclusion of torsion a significant modification needed for this theory to work. According to physicists like Nikodem Poplawski, at the densities found inside a black hole, the interaction between torsion and the spin of particles would create a powerful repulsive force. This torsion-induced bounce would be the mechanism that creates a new universe inside every black hole, making them not just cosmic destroyers but creators. Cosmic anisotropy. The evidence for a preferred direction in galaxy spins points to a concept called cosmic anisotropy, the idea that the universe is not the same in all directions. This directly challenges the cosmological principle, a foundational assumption in modern cosmology. This isn't just about galaxy spins. Anomalies in the cosmic microwave background radiation, first noted in data from the WMAP satellite and later confirmed by the Planck satellite, also suggest a large-scale alignment. Physicist João Magueijo famously dubbed this the axis of evil because it aligned with our solar system's plane, a result so strange it had to be a mistake, except it kept showing up with a statistical probability of being random at less than 0.1%. These anomalies, once dismissed as statistical flukes or errors in measurement, are now forcing a re-evaluation of fundamental assumptions, which is exactly how science progresses. The cosmological principle of isotropy has been a cornerstone of cosmology for nearly a century, so challenging it is met with significant scientific skepticism. However, as observational data from projects like the Sloan Digital Sky Survey and the Planck satellite becomes more precise, these persistent anomalies are becoming harder to ignore. If the universe truly does have a preferred direction, it would force us to rewrite our most basic models, and would strongly imply an origin story that involves rotation, just as the black hole universe theory predicts. From the impossible galaxies seen by JWST to the mysterious alignment of galactic spins, we are faced with observations that don't quite fit our standard story of the cosmos. The idea that our universe is inside a black hole, born from a cosmic bounce, offers a potential framework to explain these anomalies without inventing new physics. It suggests we might be part of an endless cycle of creation. What do you think? Are we living inside a black hole? Let me know your thoughts in the comments below. Don't forget to like, subscribe, and hit the bell icon. Thank you for watching Stellar Tech. Voyager 1, a tiny spacecraft the size of a car, is drifting through the unimaginable darkness of space, 14.5 billion miles from Earth. But nearly 50 years later, Voyager is still alive, defying the odds. Recently, this legendary probe has encountered something in the void that has scientists both amazed and deeply concerned. What has there found Voyager? The data streaming back suggests phenomena that challenge everything we thought we knew about interstellar space. Today, we explore Voyager's impossible encounter and what it means for humanity's future among the stars. The birth of a star sailor. The story of Voyager 1 began in the era of Cold War ambition, when NASA sought to expand humanity's horizons beyond Earth orbit. Under the leadership of Dr. Edward Stone, Voyager 1 was designed as a robust spacecraft capable of a grand tour of the outer planets, the first of its kind. Launched on September 5, 1977, from Cape Canaveral, it journeyed towards Jupiter with an array of scientific instruments, including the cosmic ray detector and plasma wave instrument. The spacecraft was engineered to survive decades of space exposure, carrying the hopes of mankind as it ventured boldly where no one had gone before. Dr. Stone's decade-long stewardship ensured the mission's remarkable longevity, setting the stage for an unprecedented exploration of our solar system. Built with 1970s technology that would seem primitive by today's standards, Voyager 1 was nevertheless equipped with instruments sensitive enough to detect the faintest signals from the cosmos. The spacecraft's nuclear power source, designed to last far beyond its primary mission, would prove crucial for its extended journey into the unknown. This remarkable engineering feat would soon carry humanity's message to the stars and beyond. The Grand Tour. Voyager 1's Grand Tour of the solar system became legendary, lasting over 12 years and bringing humanity close to the gas giants Jupiter, Saturn, Uranus, and Neptune. During flybys, it sent back unparalleled images and life-changing data that redefined our understanding of these colossal planets. Notably, the encounter with Jupiter revealed the planet's turbulent atmosphere and intense magnetic field, reshaping planetary science forever. The spacecraft discovered active volcanoes on Jupiter's moon Io and revealed the complex structure of Saturn's rings in unprecedented detail. Subsequent visits to the outer planets expanded our knowledge of ice giants and their mysterious moon systems. Each planetary encounter used gravitational assist to propel Voyager faster toward the edge of the solar system, a trajectory carefully calculated to maximize scientific return. The spacecraft's cameras captured images that became iconic symbols of human exploration, including the famous pale blue dot photograph of Earth taken from 4 billion miles away. Voyager's trajectory, programmed for a final sprint beyond the solar system, demonstrated NASA's engineering brilliance in interplanetary travel. Today, its legacy continues as it ventures into interstellar space, humanity's first emissary beyond the protective bubble of our sun's influence. The Golden Record. The Golden Record aboard Voyager 1 is a time capsule destined to outlast humanity itself, containing sounds and images representing Earth's diversity. Curated by Dr. Carl Sagan and a committee of scientists and artists, the record includes greetings in 55 languages and music spanning cultures and epochs. Encased in an engraved gold-plated copper disc, it serves as a cosmic message in a bottle, intended for any intelligent life that may encounter it in the distant future. The record also contains scientific information about Earth's location, using pulsar maps devised by Dr. Frank Drake, providing a cosmic roadmap for potential discoverers. Despite its age, the Golden Record remains a testament to human curiosity and hope across the void of space, symbolizing peace and universality. The record includes sounds of Earth, from ocean waves to human heartbeats, from classical music to the laughter of children. It represents humanity at its best, showcasing our diversity while emphasizing our common bonds. Voyager's legacy is as much cultural as scientific, immortalizing humanity beyond our solar system boundaries. This golden message continues its journey through the cosmos, carrying our hopes and dreams to destinations unknown. Years in the void. Years of drifting through the cold void beyond our solar system, Voyager 1 has defied all expectations for spacecraft longevity. Since crossing the heliopause in 2012, it has continuously sent back data about interstellar space despite operating far beyond its design limits. Engineers at NASA Jet Propulsion Laboratory, led by Dr. Suzanne Dodd, have managed to keep the spacecraft operational despite dwindling power supplies and aging components. Voyager's instruments continue to measure the harsh radiation environment far beyond any planet's protective magnetosphere, revealing a cosmos more dangerous and dynamic than anyone imagined. The spacecraft's telemetry reveals vital signs including temperature readings and electrical system status, a testament to the incredible engineering resilience of 1970s technology still performing flawlessly in the most hostile environment known. Each year, Voyager's plutonium power source weakens, forcing mission controllers to make difficult decisions about which instruments to shut down to conserve energy. Yet the spacecraft persists, transmitting scientific data across billions of miles of empty space. Voyager 1's longevity contrasts sharply with initial mission expectations, with scientists noting it has become humanity's longest-lived emissary in the cosmos, far exceeding all predicted operational timelines. Crossing the boundary. Voyager 1's historic crossing of the heliopause marked humanity's first journey into true interstellar space, a milestone that redefined our understanding of the cosmic frontier. The spacecraft's instruments, including sophisticated sensors and detection equipment, began recording phenomena unlike anything seen within our solar system's protective bubble. Lead scientist Dr. George Glockler from the University of Minnesota explains the significance of these observations, revealing magnetic field turbulence and unexpected plasma oscillations that challenge existing models of the interstellar medium. The boundary between solar and galactic space proved far more complex and dynamic than theoretical predictions suggested, showing multiple layers and transitional zones rather than a clean separation. Voyager's data revealed that interstellar space is not the quiet, empty void scientists once imagined, but rather a region filled with electromagnetic activity and cosmic phenomena. The spacecraft detected charged particles moving at incredible velocities, evidence of ancient stellar explosions and cosmic events that occurred millions of years ago. These measurements provided the first direct sampling of materials from beyond our solar system, offering insights into the composition and behavior of the galaxy itself. Voyager's continuing transmission from this unexplored realm offers unprecedented insights into the boundary between solar influence and the vast galactic ocean beyond our protective heliosphere. Signals from nowhere. In late 2023, Voyager 1 went mysteriously silent, sparking fears among mission scientists who had dedicated decades to the project. Analysis revealed a corrupted memory chip, likely damaged by a high-energy cosmic ray that struck the spacecraft with devastating precision. Immediate action by the Jet Propulsion Laboratory team, including Flight Director Dr. Melissa Brown, involved rerouting computer operations to back up memory areas while working across an impossible distance. This delicate software workaround, performed from Earth with signals taking over 22 hours each way, required extraordinary precision and patience from the engineering team. The rescue operation demonstrated incredible human ingenuity, essentially performing remote brain surgery on a patient billions of miles away using technology older than most of the engineers working on it. When Voyager finally responded, it brought relief to scientists worldwide who had feared losing humanity's most distant explorer forever. The incident highlighted both the spacecraft's vulnerability and resilience, showing how a single cosmic particle could threaten decades of scientific discovery. The successful restoration of communication proved that even in the depths of interstellar space, human determination and technical expertise could overcome seemingly impossible odds and continue our journey of cosmic exploration. The temperature mystery. Voyager's instruments have detected bizarre temperature anomalies in the interstellar medium that defy current scientific understanding of cosmic thermodynamics. The spacecraft's sensors recorded unexpected heat signatures and thermal variations that suggest unknown energy sources operating in supposedly empty space. Dr. Reka Winslow from the University of Michigan analyzed data showing these temperature fluctuations correlate with mysterious electromagnetic activity that creates complex thermal gradients across vast distances. These findings indicate dynamic processes previously unknown to science, with energy transfers occurring through mechanisms that current physics cannot fully explain. The spacecraft's thermal sensors detected variations that challenge existing models of interstellar space, revealing an environment far more active and energetically complex than anticipated. These thermal anomalies persist across the spacecraft's trajectory, creating a puzzle that has scientists scrambling to develop new theories about energy distribution in interstellar space. The temperature readings suggest that the void between stars may harbor energy sources or phenomena that could revolutionize our understanding of cosmic physics. Some researchers speculate these thermal signatures could indicate the presence of dark matter interactions or unknown electromagnetic processes that operate on galactic scales, opening entirely new avenues for astrophysical research and discovery. Changing course. Maintaining control over a spacecraft traveling through the depths of interstellar space requires unprecedented precision in navigation techniques and trajectory management. Dr. Carlos Hernandez from NASA Goddard Space Flight Center leads efforts to execute delicate course corrections on Voyager 1, despite the enormous challenges posed by distance and communication delays. These trajectory adjustments must account for the spacecraft's changing orientation, limited fuel reserves, and the gradual degradation of its attitude control systems after decades of operation. The complex calculations required for each maneuver consider gravitational influences from distant stars, the pressure of interstellar particles, and the spacecraft's slowly declining power output. These adjustments demonstrate unparalleled precision in space navigation, requiring engineers to predict and compensate for factors that won't be observable for hours due to signal travel time. Each course correction represents a carefully calculated gamble, as there are no second chances when working with such precious and irreplaceable scientific assets. The navigation team must balance scientific objectives with spacecraft preservation, making difficult decisions about energy expenditure and pointing accuracy. Despite these challenges, Voyager continues to maintain its scientific mission while heading toward an eventual encounter with the star AC plus 79 3888 in approximately 40,000 years. Ghost in the Machine. Recent months have seen Voyager 1's onboard computer systems exhibit mysterious glitches that have puzzled mission engineers and raised concerns about artificial intelligence anomalies. Led by Dr. Ananya Singh at NASA's Jet Propulsion Laboratory, the team closely monitors these strange behaviors manifesting as unexplained error codes and signal irregularities that don't match any known failure modes. The anomalies appear almost intelligent in nature, as if something within the spacecraft's systems is learning and adapting to its environment in ways the original programmers never intended. Some engineers speculate these phenomena arise from cosmic radiation effects interacting with the spacecraft's aging electronics in unexpected ways, while others wonder if decades of exposure to interstellar conditions have somehow altered the computer's fundamental operations. The spacecraft occasionally transmits data patterns that seem to contain information beyond its programmed capabilities, leading to speculation about whether the harsh environment of space might be inducing evolutionary changes in electronic systems. Diligent troubleshooting and software updates aim to preserve communication integrity, but the mysterious behaviors continue to manifest despite all efforts to understand or control them. These electronic anomalies represent one of the most puzzling aspects of Voyager's extended mission. Patterns within patterns. Recent analysis of Voyager's long-term data has revealed subtle but persistent patterns in cosmic ray measurements and magnetic field variations that suggest influences from unknown astrophysical sources. Dr. Emilia Garza, a heliophysics expert from the University of Texas, notes the discovery of quasi-periodic oscillations that appear to originate from deep space phenomena beyond our current understanding. These patterns within patterns challenge assumptions about the uniformity of interstellar space, instead revealing a complex structure operating on multiple scales and timescales that scientists are only beginning to comprehend. The oscillations show characteristics that don't match any known natural phenomena, leading some researchers to speculate about possible artificial origins or previously unknown physical processes occurring in the galactic environment. Voyager's instruments detect synchronizations and correlations in the data that seem too organized to be purely random, suggesting underlying mechanisms that organize matter and energy across vast cosmic distances. These discoveries have profound implications for our understanding of how the galaxy operates, potentially revealing hidden structures or forces that influence the behavior of matter and energy throughout interstellar space. The patterns continue to evolve as Voyager travels deeper into unexplored regions, providing humanity with its first glimpse into the true architecture of our galactic neighborhood and the mysterious forces that shape it. Voyager 1 continues its impossible journey into the cosmic unknown, revealing mysteries that challenge our understanding of the universe itself. From strange temperature anomalies to unexplained computer behaviors, this tiny spacecraft has encountered phenomena that suggest the cosmos holds secrets far beyond our current knowledge. As it drifts ever deeper into interstellar space, Voyager carries not just our scientific instruments, but our hopes and fears about what lies beyond our protective solar bubble. Subscribe to Stellar Tech for more revelations about humanity's greatest adventure and the discoveries that await us in the darkness between the stars. A cosmic alignment so perfect it defies chance, or a deliberate arrival we were never meant to see. On September 12, 2025, astronomers witnessed the impossible. Two colossal objects arriving from opposite ends of the universe set to rendezvous in our solar system during a total observation blackout. The official story is twin comets, but the evidence points to something far stranger. Let's explore this together. Swan's dramatic arrival. What does it look like when the impossible streaks across the sky? On September 12, 2025, we found out. The SWAN instrument, a solar wind anisotropy sensor aboard the SOHO spacecraft, flagged a new object blazing a path through the inner solar system. The first data sets, analyzed by teams led by SOHO project scientist Bernhard Fleck, were staggering. The object possessed a tail stretching nearly 2.5 degrees across the sky, about 5 times the width of a full moon. To put that in perspective, a tail of that magnitude suggests a hydrogen outgassing rate hundreds of times greater than a typical long-period comet. Its initial brightness was clocked at magnitude 7.4, luminous enough to be seen with backyard telescopes from a distance of over 150 million kilometers. This wasn't some faint smudge, this was a spectacle. News ignited across astronomy networks, and just 2 days later an amateur observer captured a jaw-dropping image showing a streak so immense it barely fit the camera's frame. It was too big, too bright, and its trajectory was already looking far too precise. The raw energy output required to generate such a visible display at that distance was the first red flag that this was something entirely new. Official recognition and growing mystery. A name makes it real but can also deepen the mystery. By September 13th, the International Astronomical Union's Minor Planet Center made it official, designating the object C/2025 R2 or SWAN in honor of the instrument that found it. Within a single weekend, the global astronomy community, from professionals using the Hubble Space Telescope to amateurs in their backyards, was completely fixated on this celestial titan. They traded images and brightness measurements across hemispheres, trying to make sense of its unprecedented behavior. Most comets discovered in the modern era are faint smudges requiring powerful telescopes, but SWAN was a spectacle for anyone who knew where to look. Its magnificent tail sliced through the constellation Virgo at a blistering pace of 20 arc-seconds per minute, growing brighter with each passing day as it raced toward the sun. The conversation quickly shifted from simple observation to intense speculation, with astronomers like Dr. Robert Warwick, the discoverer of Oumuamua, noting the statistical improbability of such a bright object appearing with so little warning. The amateur community, often the first to notice unusual behavior, was already debating what could possibly power a tail this long and this bright. It was simply too big, too vivid, and too fast to be ignored. The cosmic coincidence. Some things are so unlikely they stop looking like a coincidence. C/2025. R2. SWAN is not the only strange visitor this October. Days before, another object, 3I/Atlas, was already inbound from a completely different part of the sky. Imagine a celestial map. SWAN's path traces back from Aquarius while Atlas entered from the direction of Sagittarius. Yet both are set to reach their closest pass by the Sun within the same 10-day window. For Atlas, that's October 17th at a distance of 1.36 AU. For SWAN, it's just 3 days later, around October 20th, at a much closer 1.0 AU. Their perihelion points are separated by only about 50 million kilometers, closer than Mars ever gets to Earth. The geometry is what's truly stunning. Both are on steeply inclined orbits, with SWAN's path tilted more than 60 degrees, and Atlas nearly 90 degrees to the ecliptic plane. As orbital dynamicist Paul Wiegert would tell you, the statistical probability of this kind of synchronized arrival from such different trajectories is infinitesimally small. It's a corridor in space-time that seems to have been deliberately targeted. This is not random chance, it is a rendezvous. Atlas breaks the rules. So what happens when an object refuses to follow the laws of physics as we know them? 3I/Atlas first caught astronomers' attention by breaking all the rules. Early spectrographs from the Atacama Large Millimeter Array reported something that really set off alarms: a body dominated by nickel with virtually no iron, a ratio that's just unheard of in natural celestial objects. This, honestly, contradicts everything we know about comets and asteroids, which almost always contain iron-nickel blends, similar to chondritic meteorites. The claim was so radical that some labs immediately called for data re-verification. The mystery only deepened when its coma was found to be pumping out carbon dioxide, detected at a strong 4.3 micron spectral line, at rates 5 times higher than water. But what really couldn't be explained was its motion. Observers noted 3 distinct non-gravitational accelerations, each providing a delta V of several meters per second. These weren't the gentle pushes from solar heating, they were sharp, sudden bursts, almost as if the object had fired a thruster. The only other object that showed similar acceleration was Oumuamua, but as Harvard astronomer Avi Loeb pointed out, the pulses from Atlas seemed far more controlled and powerful. Swan, the fortress. If Atlas is a nimble drone, then Swan is a battleship. The scale of C/2025 R2 is, honestly, hard to comprehend, but it's the data that paints a radical picture. One that has driven speculators like Harvard's Avi Loeb to consider similar theories for other objects. It all began with reflectance data. Swan's core has an albedo or reflectivity far higher than a typical dark comet nucleus, matching the signature of polished metal. Some analysts even argue it fits a nickel-cobalt blend, an alloy used for its immense strength. Then came reports of a silvery halo around the nucleus, an anomaly some interpret as a plasma envelope or an electromagnetic shield. This is where it earned the nickname, the Fortress. Unlike Atlas, Swan appears steady and invulnerable, refusing to fragment as it nears the sun. Even its tail shows evidence of micro-thrusts, tiny rhythmic pulses at a consistent frequency that defy natural outgassing. Add in its 22,554-year orbit, and you have an object that appears to be ancient, armored, and on a deliberate, powered course. It isn't just passing through, it's arriving. Mission theories. Coincidence or a coordinated mission? When a long-period object on a 22,554-year cycle and a hyperbolic interstellar object arrive together, the odds of chance really plummet. This has fueled a wave of mission theories. The first, and most routine, is a scheduled refueling run, with the sun acting as a cosmic pit stop for 2 engineered probes. A second, less peaceful theory suggests an intervention or a confrontation, especially given the incredible power levels required for their observed accelerations. A third theory, championed by thinkers like Dr. Avi Loeb, proposes an audit chain. Oumuamua, or 1I/2017 U1, was the first scout, followed by 2I/Borisov, and now Atlas and Swan represent escalating responses to Earth's century of radio transmissions. Each new arrival would be a more complex probe sent to check in. In every scenario, the sun isn't just a backdrop, it's the rendezvous point, the power source, and the beacon. The idea of using a star for a gravitational assist or energy top-up is standard practice for our own probes, like the Parker Solar Probe, making this theory, honestly, chillingly plausible. Ancient connections. An orbit of 22,554 years is, well, a link to a different chapter of human history. The last time Swan would have passed was around 20,000 BCE, right at the peak of the last glacial maximum. This is where the story connects to Göbekli Tepe, a site in Turkey built around 9500 BCE. Researcher Martin Sweatman has proposed a pretty controversial theory that its pillars are actually an astronomical observatory, recording a cataclysmic comet impact that triggered the Younger Dryas climate shift. He argues that Pillar 43 specifically tracks a long-period celestial object. Mainstream archaeologists, including the site's original lead excavator Klaus Schmidt, strongly disputed this, maintaining the carvings are symbolic. Still, the timing is, hard to ignore. If Swan is on a recurring path, its last visit coincided with a transformative period for humanity. Whether that is a coincidence or a clue remains a fiercely debated question. It adds a layer of mythic resonance to an unbelievable event, suggesting we may have seen this visitor before. The blackout window. Just as things get interesting, the lights go out. From October 8th to 18th, both Swan and Atlas will pass through solar conjunction, meaning the sun's glare makes them impossible to observe for optical telescopes on Earth. This affects every major observatory, from the Very Large Telescope in Chile to the Keck Observatory in Hawaii, as the objects will be within a solar elongation angle of fewer than 5 degrees. This is a normal astronomical occurrence, but honestly the timing is incredibly convenient. Rumors are circulating of internal memos from agencies like US Space Command and the European Space Agency, directing teams to suspend high-resolution imaging. Proposals for alternative observation methods have allegedly been denied and raw data requests delayed. A handful of telescope allocation reviewers speaking off the record have described explicit orders to avoid public statements. The result is a forced silence at the exact moment when the two most anomalous visitors in modern history make their closest approach, leaving a frustrating and highly suspicious gap in the data. Underground resistance. When the official channels go dark, the people build their own. The blackout order may have silenced major observatories, but it ignited a firestorm in the amateur and independent astronomy communities. Veteran tracker Bill Gray put out a call to arms across public forums. Keep your scopes on the sky, log everything, and share the raw data on open-source servers. A distributed web of astronomers with powerful 14 and 20-inch telescopes answered. Collectives like the Ibero Tracker Group in Europe began pooling their photometric and astrometric data feeds. Leaks suggest plans to use radio telescopes to pierce the solar glare. This grassroots effort has become the only real-time source for what might happen during the blackout. It's honestly a powerful narrative of decentralized science, a global network ensuring no data disappears. When Swan and Atlas re-emerge, the first images confirming their post-perihelion behavior might come from a garage, not a government lab. This has become a testament to citizen science. Power estimates and implications. Let's talk about the energy, because, wow, the numbers are staggering. The biggest red flag for both objects is the power source required to explain their behavior. If the observed accelerations of Atlas are indeed powered by thrusters, the energy output would need to be on the order of 10 gigawatts. That's the equivalent output of 10 large nuclear power plants like the Palo Verde generating station. But Swan makes that number look insignificant. Based on its size, brightness, and the micro-thrusts detected in its tail, the most extreme estimates place its power output at a mind-boggling 10,000 gigawatts, or 10 terawatts. That is more raw power than the entire energy grid of planet Earth combined. From a physics perspective, as noted by futurists like Dr. Michio Kaku, such energy control would place its creators firmly on the Kardashev scale as a Type 1 or even Type 2 civilization. These figures push the conversation beyond academic debate and into a realm that, honestly, forces us to question everything we thought we knew about our place in the universe. The facts are as clear as they are unnerving. Two anomalous objects, defying all statistical odds, have entered our solar system on a synchronized path. One appears to be a powered drone, the other an armored fortress. They are scheduled for a close encounter during a 10-day window where they will be conveniently hidden from our best telescopes by the sun, accompanied by an official, top-down order for radio silence. This has forced the search for answers into the hands of a global network of citizen scientists. Are we witnessing a cosmic accident, a pre-planned mission, or something else entirely? Whatever the truth is, we are about to find out. Don't forget to like, subscribe, and hit the bell icon. Thank you for watching Stellar Tech.